Let's continue with some basic concept of chemistry. That is, today we are going to deal with a small topic called atomic mass. The topic may be very small, but the understanding the concept is very high. So let's discuss about this one. This is called one of the weighing machine. So you are very well known with this one. Okay. So now I am going to discuss the topic now, relative mass and standard units. What is it? Both are assigned to this atomic mass only. So I am going to split it into relative atomic mass and standard units. ಏನು ಮಾಡ್ತೀನಿ ಇದೊಂದು ತಗಡಿದೆ. ಓಕೆ, ಸೊ ನಾನು ಒಂದು ಕೆಜಿ ಫ್ರೂಟ್ಸ್ ಕೊಡ್ತೀನಿ, ಅರೌಂಡ್ 1 kg ಫ್ರೂಟ್ಸ್ ಕೊಡ್ತೀನಿ. ಆ ಫ್ರೂಟ್ಸ್ ಅನ್ನು ನೀವು ಏನು ಮಾಡ್ತೀರಿ, ಇದರೊಳಗೆ ಹಾಕ್ತೀರಲ್ಲ. ಓಕೆ, ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ 1 kg ಫ್ರೂಟ್ಸ್. And also I am placing one stone of this 1 kg. 1 kg stone. This is called 1 kg stone. So what happens when I give the 1 kg fruits and also one side I have placed 1 kg stone? What will be the equilibrium? Equilibrium will be attained same. I mean both are in the neutral. I think they are equal in manner because this contains left side 1 kg of fruits and this contains 1 kg of this stone. So what happens? So these called as relative mass. This is called, I am going to call as relative mass. Why? Because I am telling the word relative means I am going to compare the fruits into 1 kg. I am compared to the fruits to 1 kg, and this is called 1 kg stone is called as a standard unit. It is called standard unit. Why it is called standard? To measure any mass. So I have taken here fruits. You can take vegetables. You can take anything, any materials. So this is called relative mass and this is called standard unit. So this is the standard one to measure any mass. Came to know how to weigh the vegetables, fruits and everything by using this balance. Now I am going to make the balance of the atoms. Can I play? Okay, just I take here hydrogen atom. So I take here hydrogen atom and also I can place here one stone of this contains 1 kg. So may I measure this one like this? No, it is not possible. Why? Because you know that hydrogen atom is if you take any atom, that is called the smallest particles. That is called final stage of the atom's existence. I can't cut furthermore. So that's why I am not going to measure with stone or anything. So what happens? In the year of 1961, International Union of Chemists have joined. In the year of the 1961, they are going to select the carbon 12. They are going to sell this they are going to consider as select as a carbon 12 units. So how they are taking? You know that carbon having the atomic number 6 and its atomic mass. Okay, atomic mass is 12. How 12? Because 6 protons and 6 neutrons together it becomes the 12. It's atomic mass. Okay, this is 12 atomic mass. One more isotope. This is called isotope. This is called isotopes. Isotopes is nothing but the same elements which is having the same atomic number but difference in their atomic mass is called isotope. So that's why carbon is exists in the 3 types of the isotopes: carbon 12, carbon 13, carbon 14. But its atomic number will be same. So they are going to consider this one as a standard unit, like 1 kg stone. How we are going to measure the vegetables? Like this, the scientists they are going to take this one as a standard unit. Why they have selected this standard unit? Because this is the most stable isotope of the carbon atom. So they are selected this carbon 12 isotope. So now I am going to measure this carbon 12 isotope with same of the carbon 12 isotope. Carbon 12 isotope. What will happen? So this is a balanced or not? Hence it is a balanced because the mass number is same. Here also same. Here also same. This is the standard unit. This is the relative mass. Okay. What I will do? I am going to divide this carbon atom into 12 units. I am going to divide this carbon atoms into 12 parts. Why I am going to make 12 parts? Because its atomic mass will be 12 will be there. So why I am going to cut into 12 parts? 12 units because the carbon it is having the mass, atomic mass will be 12. So I am going to make it cut it to 12 this one. 12 parts, I mean 12 units. So now tell me whether it is balanced or not. Yes, obviously it is balanced, because I am going to cut into 12 parts means it is also carbon 12 and this is also carbon 12. So this is I am going to consider as a standard unit. This is called relative mass, because I am going to compare with this one. So this is way of this, and this now I am going to tell that one atom, I mean one carbon atom is equal to 12 parts metal, like this. One atom of the carbon, that is it contains the 12 atomic mass, so that is equal to 12 parts of its own element, I mean 12 units of this own element, right? So okay, now I am going to take one example. I am going to take the oxygen element. I am going to get oxygen atom. I am going to take. You know that oxygen atomic number is 8 and its atomic mass will be 16. So now whether it is balanced? Yes. How can we going to balance this one? So obviously its weight is more. This is a heavier atom. Oxygen is a heavier atom than this carbon. So that's why measuring goes downwards and this goes upside. So I want to make it balance. What I am going to do here? I am going to add extra 4 units to the right side. Means I am going to add extra 4 units. Now it becomes 12 plus 4, 16, and here its atomic mass will be 16. Now it is going to be balanced. So that's why I am going to tell that one atomic mass of oxygen is equal to how many parts? 16 parts of the carbon. 16 parts of the carbon. Like this, I am going to take here nitrogen. I am going to take here nitrogen. You know that its atomic number will be 7 and its atomic mass will be 14. So now how many will be there? 16 will be there. I am going to remove extra 2. Now it becomes 14. So like this, here what happens? It is a balance. I am going to tell one atom of nitrogen is equal to how many parts of the carbon atoms? That is equal to 14 parts of the carbon atom. 14 parts of the carbon atom. So this is the relative mass. This is the standard unit. So Hagadra, I am going to take this 1 unit. How it came here? Carbon divide ಮಾಡಿದಾಗ ಅದರಲ್ಲಿ ನಮಗೆ ಎಷ್ಟು ಸಿಕ್ತು? 12 ಯೂನಿಟ್ಸ್ ಸಿಕ್ತು. ಇದರೊಳಗೆ ಒಂದು ಯೂನಿಟ್ ನಾನು ತಗೊಂಡು ಅದಕ್ಕೆ ಏನಂತಂದ್ರೆ 1 unit is equal to I am going to name as atomic mass unit. I can tell that units also I am going to convert into one unit is I am going to name it as atomic mass unit. So I am going to replace here. What I am going to replace here? Instead of I am telling the 12 parts, I am going to tell that 16 AMU atomic mass unit. And here also same 14 parts I am going to remove here. I am going to name it as AMU, 14 atomic mass unit of the carbon. So this is the way of the understanding the atomic mass, relative mass and standard units or standard mass. And also one atomic mass unit that I am going to measure like this because of the 1 by 12. 1 by 12 is nothing but here 12 units will be there. I am going to take only 1 unit. So among the 12 units I am going to take 1. So that is going to write like this. One atomic mass unit is equal to 1 by 12 parts of the carbon. Now one atomic mass unit is going to be defined as mass equal to 1/12 of the mass of the one carbon 12 atom, or simply one atomic mass unit is equal to 1 by 12 of the mass of the carbon 12 atom. So if you need to memorize this one atomic mass unit is equal to 1 by 12 into mass of the carbon 12 atom. Okay, so here one mass of carbon 12 atom is equal to mass of the one atom of the carbon 12 is equal to 1.99 into 10 raised to minus 23 gram. So scientists has done some experiments. So after some experimental value, they are going to conclude this value. Mass of the one atom of carbon 12 is 1.99 into 10 raised to minus 23 gram. So now you substitute this value in this place. That is 1 by 12 into 1.99 into 10 raised to minus 23 gram. So what will happen? 1 by 12 into 1.99 into 10 raised to minus 23 gram. After that we are going to calculate as 1.6605 or 0.54 into 10 raised to minus 24 gram. It is in the gram. Or if you are going to take space in kg, then it becomes 10 raised to minus 27 kg. So only difference, kg is 1000 grams. So I am going to add some 1000 grams. So then it becomes kg. So whether you can place in gram or in kg. So finally we have approached the definition of the atomic mass. So what is the definition? The atomic mass is defined as the ratio, anupata, ratio of the mass of an atom of an element to the 1/12 of the mass of the carbon 12 atom. In terms of definition, okay, then it is a formula. You should need to know this one. Ratio, the mass of an atom of the element divided by 1/12 of the mass of the carbon 12 atom. So this is the definition of atomic mass. I mean, the atomic mass of any element which is going to express how many times it is heavier than that of the 1/12 of the mass of the carbon 12. Atomic mass which is going to express how many times it is heavier than that of the 1/12 of the mass of the carbon 12 atom. So example, you know the atomic mass of the oxygen is how much? It is 16. I mean, one atom of oxygen is 16 times heavier than that of the 1/12 of the mass of the carbon 12 atom. So this is the understanding of the atomic mass. In terms of atomic mass unit, so that is what mass of an atom of an element is 1.673 into 10 raised to minus 24 gram divided by 1/12 into mass of the carbon 12. So we have already got the value, that is what 1.66056 into 10 raised to minus 24 gram. So after this cancellation of this one, we are going to value as a 1.0078 unit, or simply I am going to make it as a rounded figure as 1.008 unit. So therefore, one atomic mass of an hydrogen atom is, in terms of AMU, that is 1.008 unit. So this is the understanding of the concept of the atomic mass.